So welcome to SAKALAVIDYA educational channel. So welcome to the JE advanced classes. So in this regard we are going to discuss uh, previous examination questions, that is JE advanced 2022 question, and also this is domain wise we shall discuss. First today we shall discuss trigonometry. So JE advanced 2022 trigonometry question. See Tarun, welcome. See, first let me read the question and all of you just go through the question also. Now don't try yourself for this question. So now you see, let alpha and beta be the two real numbers such that minus pi by 4 less than beta, beta less than 0, 0 less than alpha, alpha less than pi by 4. If sine of alpha plus beta equals to 1 by 3, cos of alpha minus beta equals to 2 by 3, then the greatest integer less than or equal to sine alpha by cos beta plus cos beta by sine alpha plus cos alpha by sine beta plus sine beta by cos alpha whole square. So that means we are asked to find out here the greatest integer and less than or equal to sine of cos beta plus cos beta by sine alpha plus cos alpha by sine beta plus sine beta by cos alpha whole square. Integral part we need to find out, provided that what is given actually here, what is given. So given conditions are very important here. Given conditions are here sine of alpha plus beta, so that equals to 1 by 3 given, and next cos of alpha minus beta equals to 2 by 3. So these two are given and also condition is given. With the help of this we need to find out. Okay, my dear students, how to find out this problem? What sort of strategy need to be applied to crack this problem? But actually this problem is very simple problem based on trigonometric ratios and compound angles only. With the help of these two concepts, this problem can be cracked in an easy manner using trigonometrical identities. Actually here we need to make use of actually here plans. Actually here what is our plan means. So this problem is related to the trigonometric functions, and next concept of composite, so that is compound angles, and simple rationalization part also, rationalization of sorts. And next part is to find greatest integer part, where this is the greatest integer. So these are involved in this problem. So let us try to apply our plan. So first here see, for example, you consider this one up to this one. So let us consider this value. Okay. Let us move to next page, new page. Okay, consider, say something given expression, say like this: sine alpha by cos beta, plus, go back to the question, cos beta by sine alpha, plus, okay, next cos alpha by sine beta, plus, next what do we have here, sine beta by cos alpha, right, sine beta by cos alpha and whole square. First let us simplify this value. After that, integral part of the given expression we need to find out. So how to find this one? Unless we group it. So that means sin alpha by cos beta plus cos alpha by sin beta you apply. After that, see, cos beta by sin alpha plus sin beta by cos alpha, let us perform it. So how could we change? So sin alpha by cos beta plus cos alpha by sin beta. So that means here we have cos beta sin beta LCM. So we can write sin beta cos beta LCM. Next sin alpha sin beta, sin alpha into sin beta you will be getting. I hope it's clear to you. Plus in the similar manner cos alpha cos beta, cos alpha cos beta, right? And plus write down. So we need to simplify these two. Here also what is the LCM? Here we have sin alpha cos alpha, sin alpha cos alpha, okay, cos beta into cos alpha, that is cos alpha cos beta, plus sin alpha into sin beta. I hope it's clear to you this step. And whole square. Am I correct? Okay, now I ask you one question. What is the value of cos alpha cos beta plus sin alpha sin beta? So this is nothing but, my dear students, that is nothing but cos of alpha minus beta. Am I correct now? So in the similar pattern, here sin alpha sin beta plus cos alpha cos beta also, obviously cos alpha minus beta. Now the cos of alpha minus beta. Now next step follows like this. This becomes cos of alpha minus beta divided by, this is sin beta and cos beta, plus, so instead of cos alpha cos beta plus sin alpha sin beta, we can replace, that is cos alpha minus beta upon sin alpha cos alpha. Clear? Then what will be the next step you expect? What is the next step? So next step, easily we can expect that the cos of alpha minus beta, this cos of alpha minus beta, the cos of alpha minus beta taken common out. If you, while taking common out, cos of alpha minus beta whole square it becomes. So now this can be written by taking cos of alpha minus beta from this, actually from this bracket you shall be getting cos of alpha minus beta whole square, that is cos square alpha minus beta. So now here we have 1 upon sin beta cos beta, that we write down, multiply both numerator and denominator with 2. This can be written 2 divided by 2 sin beta cos beta, write down. Even you can apply multiple submultiple concept also. This also 2 by 2 sin alpha cos alpha, write down. It makes no difference for us. Am I correct? I hope it's very clear to you. Now my dear students, see, we know that we have one beautiful concept, 2 sin A cos A. 2 sin A cos A is nothing but sin 2A. Am I correct? 2 sin A cos A is equal to sin 2A. So that means this 2 sin beta cos beta, 2 sin alpha cos alpha, accordingly we can write. So that means now we are going to write here also 2 can be taken out. So 2 square becomes, now we are going to write the next page. So that is equal to, we have 4 cos square alpha minus beta. Am I correct? And next here 1 upon, see, go back to the next step. What is the step? 2 sin beta cos beta is sin 2 beta. We can write sin 2 beta plus this is 1 upon sin 2 alpha, we can write. This is the given expression only, say equation 1 for our convenience. So now we know the cos of alpha minus beta. You check now. The cos of alpha minus beta is given, that is 2 by 3, no problem. But what we need to find out here? Here one question will arise. So what is the question will arise? How to find, you see, how to find this sin 2 alpha and sin 2 beta. So then the problem will be solved. So how to find sine 2 alpha and sine 2 beta? So now let us find out the sine 2 alpha. See, my dear students, this sine 2 alpha can be written as sine of alpha plus beta plus alpha minus beta. You check, is it correct now? So I hope it is correct. It seems to be rather, for example, you can say, so this is A, so this is B. Sine of A plus B formula. So it can be expanded like this. Sine A, sine of alpha plus beta, and cos B, cos of alpha minus beta, plus cos A, cos of alpha plus beta, and multiplied with the sine of alpha minus beta. Am I correct? Okay. Now here just given condition, you check the given condition. Sine of alpha plus beta is 1 by 3, cos of alpha minus beta is 2 by 3. Okay, sine of alpha plus beta, sine of alpha plus beta equals to 1 upon 3. So we have cos of alpha minus beta is equal to 2 upon 3, right? But we should know the value of here. So we should know the value of cos alpha plus beta and sin alpha minus beta using these two values. Okay. So now I will try to get those values also. As sin alpha plus beta is equal to 1 by 3, we know that cos theta is equal to, that means cos of alpha plus beta is equal to, you can write square root of here, square root of, see, now we can write square root of 1 minus sine square alpha plus beta, that is 1 by 3 whole square, 1 by 9. Obviously this will be square root of 8 by 9, 4 into 2, that is 2 root 2 by 3. I hope it's very clear to you. So in the similar lines, here we can find out sine alpha minus beta also. Sine of alpha minus beta equals to square root of 1 minus cos square alpha minus beta, that is 4 by 9. So now we are going to get this value is equal to, so now this value is equal to root of 5 by 3, root of 5 by 3. So let us substitute the values, So now we are going to get sine alpha plus beta is equal to 1 upon 3 multiplied with cos alpha minus beta is equal to 2 upon 3 plus cos alpha plus beta is equal to how much? 2 root 3 upon 3 multiplied with sine alpha minus beta is equal to root 5 upon 3 you will be getting, right? So now let us simplify this one. This will be 9 will be the LCM. So 9 will be the LCM, 3 3 ja. So now we can write 2 plus 2 root 15 you will be getting. 2 root 15 you will be getting. So am I correct now? I hope you got it now. So this is actually sine 2 alpha. Now we need to find out sine 2 beta now. What is sine 2 beta? Sine 2 beta means we can write sine of alpha plus beta and minus of alpha minus beta. You check it. What do you get now? You get the same step itself only. It is in the form of sine of A minus B. So sine A, sine alpha plus beta. So this is cos alpha minus beta. And next minus cos alpha plus beta and sine alpha minus beta. So let us substitute the values. So this is nothing but actually you will be getting directly 2 minus 2 root 15 by 9 also we can write. This will be 2 minus 2 root 15 upon 9 you will be getting. So now from equation 1, this cos alpha minus beta is replaced by 2 by 3. So that means now we are going to get like this now. So now, okay, from 1, given expression is equal to 4 times cos square alpha minus beta. 4 times cos square alpha minus beta is equal to 2 by 3 whole square. 2 by 3 whole square is 4 by 9 and multiplied with 1 upon see 1 upon sine to beta, that is 9 by, you will be getting 9 by, right, 9 by 2 minus 2 root 15 plus this will be, see, you will be getting, this will be how much, 9 by 2 plus root 2 root 15, right, 9 by 2 plus 2 root 15, right. So 9 by 2 you can take out 9 common and 2 common, we have 16 upon by 9 and 9 common, we have 1 upon 1 minus root 15 plus 1 upon 1 plus root 15. Okay, 9 gets cancelled, we have 16 times, here LCM is, we have root 15 1 minus root 15 1 plus root 15, that will be how much you will be getting. Let us go back, okay, this is 2 root 2, sorry, here 2 root 2, we have 2 root 2, this also root 5, you will be getting 2 root 2, this is 2 root 2, sorry, root 10 you will be getting, root 10, okay, this will be root 10, so we have root 10 and also root 10, clear. So next, what do you get now? Right, okay, so now here you will be getting 1 minus 10 and 1 plus root 10, 1 plus root 10 and plus 1 minus root 10 you will be getting. So root 10 cancel, you have 2, 1 plus 1 is 2, 2 divided by 16 times 2 divided by negative 9 you will be getting, right. So here this is nothing but whole square we have, this is also whole square. Wait one minute, we did a mistake here, so we did mistake, yeah, so we need to simplify once again, right, let us wait. Here you will be getting how much, 3 into 3 9, okay, right, that's correct, okay. So now 9 by 2 common, that will be 4 times 4 by 9 into, this is 9 square is 81 by 4 you will be getting, and 1 minus 1 by root 10 plus 1 upon 1 plus root 10 whole square. Am I correct, my dear students? Just check it now. Vamshi Chinna, right? So this will be 9 1 ja, 9 9 ja, 4 1 ja, 4 4 ja. This will be 16 times here. So product of these two, a plus b into a minus b, 1 minus 10, that will be minus 9. And next you will be getting 1 plus root 10, 1 plus root 10. And also here we have 9 also, 9 into, right, plus 1 minus root 10 whole square. Root 10 cancel, we have 16 into 9 into 2 by minus 9 whole square, that will be 4 by 81, 9 1 ja, 9 9 ja, right, clear. So this will be 2 square by 81, 9 9 ja, this will be 64 by 9, right. So now the 64 by 9 we need to divide with 2, 9 7 ja 63, you will be getting 1, right. So that means actually integral part of the given integer we need to find out. Here integer is how much, 7, so answer is 7. So in this way we need to solve the problem. Actually you can check that some calculation errors may be there, but you need to rectify the calculation errors, but you need to follow these steps. So first you follow this one now. So this is the question, right? This is the question. Sin alpha plus beta is equal to 1 by 3 and cos alpha minus beta is equal to 2 by 3, right? Next simplification. Okay, this cos alpha minus beta taken common out, right? This is cos square alpha minus beta. Next multiply with 2. So next step is 4 cos square alpha minus beta, 1 by sin 2 beta plus 1 by sin 2 alpha. Next sin 2 alpha is sin alpha plus beta cos alpha minus beta, that is 1 by 3 into 2 by 3. That will be 2 by 9, this will be 2 by 9. Plus next cos alpha plus beta, cos alpha plus beta is equal to, so 1 by 1 minus sin, that will be root of 8 by 9, 2 root 2 by 3. So write 2 root 2 by 3 multiplied with, this will be sin alpha minus beta is root of 1 minus sin alpha minus beta is 4 by 9. So root 5 by 3, root 5 by 3. I hope it's clear. Now 2 plus 2 root 10 by 9. This will be similarly 2 minus 2 root 10 by 9. So now 9 by 2 minus 2 root 10 plus 9 by 2 plus 2 root 10 whole square. This is 4 into 4 by 9 and 9 by 2, 9 by 4. So 9 square means actually 81, 9 9 ja and 4 4 cancel. This is actually, here we have what we have. Okay, we did mistake here, so we need to check. So we need to check this step. This step is very important, my dear students. We need to remember the step. So this is equal to, we have 9 into 4, 36. So 36 multiplied with, we have actually how much we have, 2 plus 2 4 by 81. Okay, 9 9 ja, 9 6 ja, 64 by 9. Okay, now the 64 is divided by 9. 64, sorry, this is not 64, not 64 here, calculation error. 6 4 ja 24, 24 by 9. This 24 divided by 9 is 9 1 ja 9. So this will be 9 2 ja 18, right here. So we have 9 into 4, 36. 36 is 4 by 81. 9 4 ja, this is 9 4 ja 9, 16 by, right, this is 16 by 9. So 16 divided by 9, 9 2 ja 18, 9 1 ja 9, you will be getting 7. This is nothing but 1 7 by 9. So integral part of the given integer, that is equal to integral part of 1 7 by 9 is equal to 1. So this is the answer. So my dear students, please remember the answer is 1. Clear? So now answer is 1. I hope it's very clear to you. So we shall move to the next question tomorrow. So but for example, JEE advanced means actually very lengthy problem, but we need to discuss all the concepts we have to keep in mind, and calculations are very important, and you need to make the plan. So in this plan actually we applied the trigonometric functions, that means identities we have applied, even the concept of the compound angles we applied, even multiple and submultiple applied, and rationalization concept applied. After that, greatest integer function concept also applied. So that means while doing the calculations we should be very careful in the examination. I hope you understood. So we shall meet you with next one more wonderful question on JEE Advanced 2022. Thank you. Bye bye. Goodbye.